The schedule is pretty tight, so let me just start with the introductions, and hopefully by the time the first presentation starts, there'll be a few more people will have joined. So it's 30 minutes for 3 presentations, each of 10 minutes, and I would like to thank Martin and Andrew for joining us today to present topics dear to their hearts. We'll try to have a little bit of time for question and discussions, and everything will be posted on YouTube. The session is recorded. If we can get the presentations, I'll post them also on Slack. So Martin, do you want to try sharing your screen?
Yes. So you should see that.
Yes, nice picture.
That's just behind me. Yeah, I just wanted to give a little bit of background on Greenwaves. So we're a French fabless semiconductor manufacturer doing really basically chips for ultra low power signal processing neural networks. We've got a product in production, and we have a tool chain that processes, quantizes, optimizes, analyzes, help with debugging graphs all the way through to code that runs on our chip. We import both TF-Lite and ONX graphs, so we're pretty familiar with both. We like ONX a lot. I'd really like to stress this. Yeah, it's great. It's very understandable. The documentation is fantastic. The operator versioning is great. There are other graphs that we import that don't have any of these things, and so we're very, very pro ONX. But there are two areas where we really would like to see some improvements, and we've got some suggestions around, which is quantization and what I'm calling fusion friendliness, but you'll see what it is. So quantization, at the moment, the current status in ONX is you've got lots of different data types. You've got some fake quantization operators, and you've got a few kind of quantized implementations of operators. But I think ONX should pose themselves kind of a question, which is what's the goal? Are you trying to directly express an ONX quantized graph? I just mentioned, we currently support graphs with mixed float 16, B float 16, 16 or 18 or 8-bit fixed point. We have, sub-byte quantization on and there's a lot of different possibilities there with different types of, scaled, asymmetric, symmetric quantization. And we even, we have our kernels are all in open source, so people can modify them as well. So there are some customers that are doing even more specialized things. And it seems to me kind of impossible for ONX to follow all of that. Because you'll have, you're not going to have quantized operators that can cope with all of these different schemes. So the other approach is to provide, the information necessary for a backend to quantize the graph or execute a pre-quantized graph. So give us enough information that we know how the graph has been quantized and at least the statistics of the activations. So, we need more information for that. Obviously we get the parameters, and mostly that gives us enough statistics unless they've been pre-quantized into, int 8 or something like that, at which point we've lost a lot of information. But the activation statistics are definitely not. So we have no information on the activations, what are their ranges, and so on. TF-Lite at a minimum now has min-max information on tensors once the graph is quantized. And there's also enough information because they use a scaled asymmetric quantization, there's enough information in each tensor to recover the original tensor, not in its entire accuracy, but we can recover it. It would be nice to add this. Basically, absolutely necessary would be min-max. It would be, I think, very easy to add standard deviation and mean information into a tensor. If the tensor is quantized, something on how to get back to the original tensor. And then there would be probably nice to have things like outlier statistics, maybe channel per channel information, maybe distribution information. I think that's something that could be discussed among people to find out what the information is, but at least have a place that could be stored and stored by the exporters. And it should be very easy to strip this information out if the ONX format graph is going to be used by runtime and you don't want the extra space that it's using. So that's kind of the first suggestion. The second suggestion is around this kind of fusion friendliness or optimized kernel friendliness. So currently, you have some fused operators like LSTM, RNN, GRU, some others. And the GRU support is highly appreciated. It's not available on TF Lite. And now that the Microsoft team very nicely have done, the tensorflow-onnx team have done support for it, it works great. And it's really useful for us. And there is a move that I sense towards using functions for composed operators. And the problem that we have is, we're working on a platform that has very highly optimized, and we're really interested in, kind of like microwatts of power consumption. So we really spend a lot of time optimizing kernels. And once you've broken up something like a GRU into a load of loops, and if statements and whiles and structures and fundamental operators and multiplies and so on and so forth, it's extremely difficult to get back to something that's really optimized, particularly if you've got custom hardware and particularly if you're doing quantization. What the idea that I had, and it's just an idea, is kind of encourage exporters to somehow group what they're exporting with some kind of higher level container, and maybe that container is a function, and name that container in the sense of relating that container back to the original graph, which was the source for this ONX export of the graph. So have some kind of namespace, perhaps just the namespace of the original creating node, like TF Keras experimental peephole STM cell, which is one I found today. But I mean, it could be anything like that, some kind of relationship back to the thing that actually caused this thing to be created. Then you have the choice of both worlds. You either have kind of a function with operators inside it. You can choose to execute those operators which are inside, so you have a general solution, or you can map from that particular named function onto some kind of optimized kernel that you've got on your particular backend. So that's the second kind of suggestion I have. Both of those things would be highly valuable to us. And that's it. Hopefully that was under 10 minutes. Yeah, update. Any
you
questions?
did great. Anybody has a question? Yeah, absolutely.
So can we go back to the slide regarding the functions and
yeah. Oh, this one. Okay.
Yeah. So I didn't quite understand the exact problem and asked. So today what happens in ONNX is we decided this move towards functions is because any new operator which can be composed by primitive operators, we said that we would add them as function ops instead of primitive ops. And the idea behind this was all the different runtimes have different goals depending on the hardware, depending on the scenarios they're trying to solve, right? So we didn't want all to impose this new burden of implementing every single operator for the runtimes, right? So the idea is a function op will appear as an op in the ONNX graph. If the runtime doesn't have an optimized kernel for that operator, then it can inline the function body.
Understood.
And then execute that graph. So today, if your runtime does have optimized kernels, then
so my point is perhaps badly explained, is when an exporter starts exporting stuff from, say, a peephole LSTM cell, right? And we decide that, and it happens that ONNX doesn't have a implementation for that. I don't know whether that's the case with that particular operator. I'm just using it as an example. At that point, it should be possible to create some kind of thing like a function, not the functions that are there at the moment, but a function that's labeled peephole LSTM cell and create the graph that implements that inside it.
So actually in the latest ONNX release, we added something which may cater to your ask. So we added an ability to import model local functions. So up until now, the functions that we had were schema-defined functions, right? And for that, those functions needed to be defined in the ONNX standard. And that's when the converter understood, okay, this is the function that's available.
Okay.
Now, with model local functions, what you can do is if a converter encounters an operator which is not available in the ONNX standard, which is not defined in ONNX standard, then they can simply put that operator as a placeholder and include the function body into the model proto. So today what they do is, today the converters have to find a way to figure out what's the function body, what is the representative body operators for this particular op, and then they directly include it in the main graph. So now with model local functions, it is possible to do that. I mean, we can talk about more details and figure out if there are any missing pieces, but the intention of adding model local functions was also to solve one of this problem.
Yeah, I think that sounds great, but I think there's an extra step, which is kind of the step of saying, this is the best practice that we would like to see in converters. You know, of saying, okay, we would like converters to label, to kind of comment what they're exporting in a way that's machine readable. And that's I guess what the suggestion is here. I agree that, you know, I mean, it sounds like you're going in the right direction from a technical structure perspective, but I think it also needs to be sort of a guideline as well, because otherwise no one will do it, basically.
I think your point is well taken. I think there's a little bit of an issue too, because I'm not an expert in converter, but I know that they do some layout optimizations, sometimes for convolution, for example. So because the converters also do some optimization, it will, having a name or function like this will have an impact. And sadly, you know, some people will want the optimization and some others will not want them. And so it becomes a little more complicated, but I think nevertheless, it's a very interesting problem.
But usually you can switch the optimization off in the converters. So, you know, then it would just export the thing in its most horrible manner, and then you try and recompose it afterwards.
Yeah, no, exactly. So I think there's definitely interaction with optimization, but that's wonderful. Okay, so in the sake of time, let's continue. And I think the next presentation touched some similar issues. So it's perfect.
How do I?
I had a quick question.
Oh, yes, absolutely.
So this is the first time I'm joining this meeting. So, so if you want to discuss more on this topic, what is the right forum to do? Should we move to the Slack channel?
Yes, exactly.
Because I see a few hands are up. Gary and Tom both had their hands up. So if you want to continue the discussion, should we take it to the Slack channel?
Absolutely. And I think we also discussed, eventually, I think those issues should migrate to the SIG that is most close to the issues at hand. So that would be our recommendation. But absolutely. Or we can also schedule an extra meeting, so whichever works best.
This would be well within the operators SIG, right? At least this topic.
And converter a little bit too.
Oh yeah, maybe.
I'm on the Slack channel, so I'm happy to have a discussion on it.
Yeah, okay. I'm glad that it generated a lot of discussions, and I think that's exactly the goal. So, and that's what we're looking for, is like to include new people in the discussions and make progress on those issues. Andrew, do you want to go ahead?
Hey, certainly. Alex, I actually sent you the charts that I've got.
Oh, I see. So you want me to present?
Well, only because it turns out I'd have to restart Zoom to present. So I don't want to leave everybody.
So, sure, absolutely. So I downloaded it. It should be.
So while you're getting that up, just a little bit of background. So my team actually is working with Alex and some of the other IBM folks. You know, we're a bit, I'll say, more recent to this space. Our focus is around, you know, enabling some of the different technologies on the AI side with some, you know, upcoming developments that we have around this IBM Telum chip that we announced a couple of weeks ago. We're looking to exploit basically ONNX and then ONNX, MLIR in particular, right across our mainframe operating systems. We do have a Linux operating system, but we also have other operating systems that don't have perhaps the ecosystem, right, that we have on x86, of course, or et cetera. And so ONNX is really a great fit for us, right, for that, along with the ONNX MLIR project that, together this gives us the ability to deploy something to these different operating systems that, is lightweight and doesn't have a huge number of ecosystem requirements. We tend to be dealing, probably like some of you, with a lot of, that are with a vendor, with a lot of enterprise clients that are in the financial space. So we tend to see cases around things like fraud detection, and other use cases like that. Less so around things like, object or image types of models. So with that, I've got a couple of broader items here. My team is and can continue to work on providing more details, but we definitely didn't want to miss the opportunity here to provide some feedback. So the first one was on basically at a high level, this concept of end-to-end pipeline support. And it's just an area where we think ONNX has and can have a great deal of value. A few of the topics here, really are that one, we like the direction that things are heading and hope to continue to see a direction of enabling ONNX operators across both, ONNX and ONNX ML that enable not just the execution of models, but also the execution, of some of the data preparation stages. And the focus on that both in not just the ONNX proper project, but the converters. We're seeing that there's, and I think not just for us, but I'm assuming for other vendors, a lot of potential value in there. And the ability to expand that to cover, other types, of data preparation operations, whether they're coming from, and I know this branches into the converters, whether they're coming from Scikit-learn, or the TensorFlow experimental preprocessing layers, is something that we think, creates in edge use cases and use cases like what I've described earlier around the mainframe, something that's a more embeddable and maintainable unit, for clients, and other users of the various services here. It also gives the user the opportunity to optimize data preparation without rewriting, So what I really mean by that, and one of the things we've encountered, is that we see these cases where latency really matters. And I would imagine, again, depending on the use case, for edge, that could also really matter. Cases where, we have a data scientist that's, working with someone, and they've, built their pre-processing pipeline, and we know in Python, that can be very expensive. So what we've tended to see a lot of users doing is going forward, and then when they do have a use case where latency is really critical, basically rewriting that those preparation stages in something like Golang. We've seen Golang for this type of use case pop up a few times, where there isn't really a really popular, from what we've seen, standard library out there. So we think there's an opportunity for ONNX really to continue to gain mind share there, because there's the potential of saving not just the effort, but then the inconsistency that can introduce. Like I said, that continued focus and work on the pre-processing primitives and converters, I think is also going to be key. I know there's challenges around the cases of things like custom Python transformations and custom transformations, but I think what we've seen, even focusing first on the easier, low-hanging fruit around the more standard conversions, has a lot of value. The other thing that, that something like this can provide, as I hinted at earlier, is that capability of the multi-model support, and really simplifying deployment artifacts and governance. And I understand with something like the ONNX runtime, you do have the ability to chain together multiple ONNX models. But I do think, and we'll be happy to provide more input on this in the future as we start to explore it more. I do think that ability to simplify to a single or common deployment artifact or model, ONNX model, could also have value. So again, from our standpoint and from what we've seen, some of the challenges, not just on our platform, but some of the challenges we've heard from clients on the other platforms they're working with, I think there is a potential, a lot of value here to continue on this path and broaden it. So I'm going to pause here for any questions. And like I said, we will be happy to get involved and start providing more details as we are entering in a phase where we expect to be, working with clients a bit more and working as a development team a bit more on some of this. So if there aren't any questions, you can, oh, is there a question? I'm sorry.
Hi, I'm Xavier Dupré. I'm working on the Scikit-learn converter. And it's not like a question, but just to confirm that I faced a similar issue that you mentioned here. And I started to propose some option like merging ONNX, several ONNX to get a single ONNX graph, or try to find better ways to help users write, convert their custom code into ONNX, which is not easy. So more like a comment than a question.
Right. Okay. Yeah, and I think what we've seen is with some of the clients that we're involved with, and I'm sure that there are other folks on the call are probably involved with some of them in similar capacities. They can tend to be very siloed. And so what ends up happening is you get people looking at some of these, deploying some of these units or some of these packages that are less familiar with some of the technology here. And I think there's an opportunity as a community to simplify some of that, and really that can be an avenue to getting better adoption, right? Or continuing to get better adoption. I can touch on the second item as well. And
so one more question on the multi-model support. That is basically an ask for an ensemble of models to be represented as a single ONNX graph, right?
It is. I think the most obvious use case that we're seeing is, cases where the data preparation pipeline in something like Scikit-learn, for example, maybe doing data preparation for a TensorFlow model, right?
Got it. Okay.
Right. So you have two things that convert basically through separate converter technologies or packages, and right.
Got it. Thank you.
I think Martin hit on probably some very similar points here. And when I proposed this, and I know this gets in very much more into the converter SIG, probably part of this, but what we're seeing in particular with some of the types of models that are really of interest is the focus on a single TensorFlow converter. Now that TensorFlow has absorbed Keras, I think is a really positive step. That loss of ability, right, at least at this stage, to represent the higher level layers, though, is for us as an example, and I think to the points Martin raised, that is a bit of loss of opportunity. What we see is, of course, the Keras graph gets broken down into the complex functions or operations, which involve, of course, a lot of loops. For something like an LSTM layer, it's something that's much more difficult to optimize, especially when, of course, we have, or you're in an environment where you have a custom accelerated form of that operation. I did notice after the fact, after we suggested this, that at least for something like the TensorFlow-onnx converter, for example, there are a couple of issues open that appear to be moving in what we feel was a positive direction, of being able to represent the LSTM operation in ONNX stemming from a TensorFlow graph that had it. But again, I think just in general, this would be I'll say I echo a lot of Martin's comments, and I think it would be a general movement in the right direction. I don't have a feel for, what the best implementation would be. And what I mean by that, I think during the discussion with Martin, the idea of name spacing came up. And I think, something like that would probably be, right, also a really good path towards making it easier on the back ends to to optimize some of this. I did put out a example of a fraud detection model that's I'll say a proxy for something we've seen. So I included a link here, just again, so there was an example to point to that uses some open data, and it's really a relatively simple, right, 2-layer LSTM model. So I know we did cover the same topic a bit in Martin's session, so I'll just stop here and see if there are any questions.
Just a comment, I actually had a customer this week converting quite a complex audio GRU graph using the tensorflow-onnx converter, and it worked great. So it looks like the issues of, there's one of those issues, the GRU one that was closed, and it works great.
Okay, great. So and it could very well be the case that, like I said, we put in this input probably a couple of months ago, and maybe at that point it wasn't. I think it wasn't there yet. So we'll take a look at that again, and we are. I'll say, as I said here, right, we are investigating this further and trying to get some more examples of proxy models, basically, of the types of things that customers are using in enterprise environments for non-image types of use cases. So as we get those, we'll definitely bring them forward.
I see somebody with a raised hand. You're welcome to speak.
Oh yeah, cool. Yeah, so I'm Tom. I work on the TF to Onyx converter, and I actually did the GRU thing, which turns that into single op. So I think some of the stuff which Martin was talking about earlier, there's like some overlap here. One thing which is different is that in this particular case with GRU and LSTM, they both are supported in the Onyx spec as single ops. And the reason we were not converting them correctly was just because whenever we're working in TensorFlow, the Keras splits it down into all of the compositions. I think that is the GRU and LSTM are the only two cases, to my knowledge, where that really occurs. I don't really think that should happen too much in other areas. Like Keras is, inherently higher level, but because Onyx has mostly low level ops anyway, most of the time those things are getting, broken down. But with LSTM and GRU, those are like the two cases where Onyx has big high level ops for them, and TensorFlow is representing those at a low level and Keras is at a high level. We've been trying to close that, and we did the GRU for one of the cases. There are a few different cases where TensorFlow splits those out differently, and we'd like to add support for all of them, but I'm not sure if we're going to have the I don't know what the timeline is on those, but of course, if you add more GitHub issues, then that is going to add more, I think, priority to getting it closed, and just like adding patterns to recognize those. Once that's added, then I think that it will be really pretty solid for LSTM and GRU.
Oh, okay, great. So I'll do that then. I wanted to wait till after this discussion, but I think, Alex, we did talk about probably opening up issues, and I know, Tom, I think I posted in your in the project discussions forum, and you were nice enough to answer me, so I appreciate that too.
Cool. Yeah.
Go ahead. Well, thank you. This is fantastic to have a like a connection directly like this. I have a follow-on question for Martin. Like for the LSTM and the GRU, this is a case where basically there's two representation in Onyx that are possible, both a high level and a low level. And for you, Martin, do you find that often there's a Keras operation, but there's not an equivalent Onyx high level, so it gets broken down to a low level, but you are able to accelerate better if you still remember the high level that is not currently supported in Onyx as
I mean, we're working day to day on loads of customer models. So it's sort of kind of yesterday's problem is the one that's the most high in my mind. Well, in fact, today's problem. I think the reason for my namespacing idea was to give us a way out in that situation where that it is being broken down, because once it's been broken down, it's pretty difficult to go in the reverse direction. It's kind of cow to mincemeat, and you can't really go back, which is not very politically correct. But anyway, it's difficult to do, and that's why I was suggesting that. Generally, though, now with the work that was done recently on the GRU stuff, it seemed to work very well for quite complex graphs. I've yet to try it with an LSTM because I've yet to have a customer who was asking me about that. And there is a path for LSTM via TF-Lite, whereas there isn't for GRU at all. So this is the only way that you can get a Keras GRU or TensorFlow GRU graph into a format that can be read by a converter, by a backend, without a loop and all of the...
Yeah, makes sense. Tom, go ahead.
Yeah, as far as the breakdown occurs, like there are definitely a lot of ops where we do that breakdown in the converter. For the GRU, it happens to be that breakdown's happening in TensorFlow, right? Like what we're seeing is actually already broken down. We're not doing the breakdown. And in order to turn that back to a GRU, we have to pattern match and reassemble it. But in the other cases where that breakdown occurs in the converter, you do kind of already have an escape hatch, which is if you convert with the -- custom ops flag, then it will leave that TensorFlow op as a single atomic op that will get put into the ONNX graph, and it will just put the domain as TensorFlow. And that might work for your purposes because that will work in cases where there is no equivalent high-level ONNX op that has all of those characteristics. And then, of course, in order to run the thing, you'll have to have, but you already said you're working on these optimized kernels and stuff. You'll have to make a kernel that works for it.
Sure. And what about the idea of making it a function?
Yeah, so I like the idea of the model local functions are pretty cool because they let you have both the definition and the high level representation. The issue with the optimization, which I think was mentioned, is that whenever it's broken into low level ops, we're able to optimize through it. And some of those optimizations are like really affect the break it so it does not have the same characteristics as the original thing, right? So it seems to me that it's probably best to explicitly denote when you're converting whether you want it broken down or not, because if you say that you want it broken down, we push optimizations through it. Now, at the same time, if you want it broken down, I can see value in just having some way to trace back where that thing came from. And yeah, it seems like once the optimizations are allowed to go through that thing, there's no way to make it machine parsable where it will be like robustly identical to the original TensorFlow op in terms of semantics. But there is probably a way to make it so that you can at least figure out exactly what op it came from. Like currently we are, kind of preserving the name, but we actually don't in TF to ONNX make it a top priority to keep the names like really similar to what they were before. So often you'll just get like underscores with different numbers on them. It seems really difficult, unfortunately, to make it so that it's like completely high level parsable, have the same op semantics and everything, just because the converter, whatever it does those compositions, sometimes makes decisions based on the properties of that particular op. Like it will only convert it to a certain composition in if the value of an attribute is one thing or whatever, and then might move around the internal pieces. So it seems like using -- custom ops might be the only way to do it robustly. And then we could also improve the naming. If we use model local functions, we can at least represent that that's a cluster of ops that came from a certain thing, but we won't be able to say that the op semantics are exactly the same as what they were originally.
Yeah, I think from our perspective, having the function with the stuff, even if it's if it's properly named and then we can relate it back to the original function, is more important than the optimization, because we have a huge amount of optimization in our backend anyway for doing some of the things that you do. I mean, things like, for example, CHW HWC conversion, because we have kernels that operate in both. So we have optimizations that handle that. And in fact, handle that through reshapes and things like that, which I don't think you do it currently. So
yeah, interesting. Yeah, I'm almost wondering, like, could there be a third option where you say that for a certain type of TensorFlow op, you want that op to be preserved in terms of semantics?
That could be a good
Yeah,
solution.
I was thinking about something along those lines, where basically you have almost a language where you can express which operation and sometimes even which parameters or type of parameters you want to be preserved, and then they could be ignored.
Yeah, I think that's a good idea. I mean, I do agree that this isn't a standard operation. I totally understand that.
Okay, yeah. And would that be helpful for you? Like, if, as opposed to using custom ops where it would just get dropped in as a TF op, is it better for you to have the full function body in both ONNX and at a high level, or would just having a TF op be sufficient?
For us, the TF op would be sufficient. I mean, the only thing about losing the stuff underneath is that we can't then use ONNX to as a kind of proof of result along the chain,
right?
Which we tend to do this kind of going back down the chain, doing a proof of result at each tensor, so that we can see where error is creeping in for different reasons, either operator differences or implementation differences or quantization.
Okay, yeah. I mean, for making a model that runs on both ONNX runtime and on your custom kernel set, having it using model local functions in a way that retains semantics of the TensorFlow op would be a pretty cool thing.
Yeah.
But I must also add that the danger of this approach is that then we become TensorFlow centric, and so one part of ONNX is also to be able to come from various different places. So
I don't see it as being particularly TensorFlow, because I mean, it's any backend platform that's producing something should produce this semantic. Any front-end platform that's converting to ONNX, I don't see why any front-end platform shouldn't be doing this.
Okay, exactly. But I mean, if you embed the TensorFlow name in it, so you lose PyTorch or some other framework. So basically, I think we almost coming to a point that if you still want to be generic, if you have a high level name, it's almost like it should belong to ONNX, because it needs to be defined and generated by the various different front end. It's just my opinion, but I definitely see the attractiveness of having a high level.
Kind of a named subgraph. I would almost not
Exactly.
think of it as an operator. It's a named subgraph.
Yeah, but it has, as soon as it has semantic meaning, right, it is really need to be defined. Because you're not going to look inside to see what it is. You're just going to assume that name and then match with something. In any case, so I think it's a very good discussion, and we're going to solve the ONNX all problems today. But I think it's great, first of all, to see the synergy between several of those issues, and also that we have people from various different backgrounds that are very familiar with those issues and can help. And I think, as Rajiv was saying, I think the next step will be to present more deeply to those SIG graphs, SIG activities, in order to continue in the discussion, having more of the people that are really very knowledgeable about the situation. Any other parting thoughts? Well, if not, thank you so much for participating again, and we'll see you. The next meeting is I had it somewhere. On the September 22nd, 5:30 to 6 PST. And see you there. Thank you.
Thank you.
Thank you.
Bye.